Hi everyone, this is Ashish Kumar and I'm working as a backend developer in the industry for around 3 years now. And in this video, we're going to see a very interesting problem, that is find all anagrams in a string. Now, this problem has appeared in multiple interviews, and especially if you go for an interview of a company like Flipkart, Microsoft, Amazon, then you can definitely expect a question like this. So this is a string based problem and it has a very unique approach to solving it. And we're going to see how we can solve it in the most optimized approach possible. So let's take a look at the question, what it is asking us to do. So the question name is find all anagrams in a string. It states given two strings S and P, return an array of all the start indices of P's anagrams in S. So we have two strings, S and P. Now we want to find all anagrams of P in S, and wherever there's an anagram, we have to return the starting index. So we have to return all the indices in an array list or in an array, anything, and the order of the indices doesn't matter. You can return the last index first or the first index first, anything, it doesn't matter, but you need to return all the indices. Okay, now before going deeper into the problem, let's understand what anagram means or what is an anagram. So let's see that. Now, so like the question says, let's assume two strings. So you have S is equal to, let's say, A, B, C, and let's say you have P as something like B, C, A. So these two strings, are they anagrams of each other or not? How are you going to learn that? So anagram basically is any string's permutation of the exact same characters is an anagram. So if you have two strings and they have the exact same characters in any order, then they are anagrams of each other. Take a look at S and P. So you have A here, you have A here, you have B here, you have B here, you have C here, you have C here. So all the characters that are there in S are there in P, and they are exact same characters in S and P. So yes, they are anagrams of each other. The order doesn't matter, it can be any permutation, but the exact same character should be there. Let's take a look at another example. Let's say you have S as again A, B, and C, and you have P as something like C, A, B. Are they anagrams of each other? Yes. Why? They have the same exact characters. Now let's take a look at another example. You have A, B, C, and then you have P, S, B, B, A. Now are they anagrams of each other? No. Why? Because the characters are different. Okay. So for two strings to be anagrams of each other, they need to have the exact same characters. Remember that. Okay. Now coming back to the question, what are they asking? You have a string S. Okay. Let's say the string looks something like this. You have C, A, B, D, E, B, B, A, C. Okay. And then you have P as, let's say, B, C, A. So you want to find all anagrams of P inside string S. Okay. So just by looking at it, you can see that BCA is appearing here, one anagram is here, and then one anagram is here, right? These two anagrams you can see directly by looking at it. So the answer, you have to return the starting index, meaning this and this. So this and this you have to return as a part of your array list or array. Okay, so how can we solve this problem? Now, just by looking at it, you might think of a naive approach or a brute force approach, where what you can do, you can have two loops, one inside the other. You can nested loops. You can have one loop for the string, for the length of string S, and one loop for the string length of string P. And what you can do is, for each like length of P, you'll check whether they are equal or not. So you'll have nested loops, right? But that will work, but that's not the best approach. That's not the most optimized approach. The time complexity of that will be quite high. We want the most optimized approach. So how can we do that? Let's think of that. So you can use something which is called a sliding window approach. Okay, and this is something which will help you going in the interview of the top product based company. Definitely you can expect a couple of questions which will use sliding windows. Okay, so it's a very good technique. So we have sliding windows technique which can be used to solving this problem. Let me explain to you what sliding windows technique actually means. So what you have, you're creating a window. Now don't worry about the word window. Window is just like a group of characters, like a grouping of characters. So we'll create a window inside S and we'll be sliding that window. Let me explain what that means. First of all, understand one thing. Let's take this example itself. What is the size of P? Size of P is 3 here. Okay, that means that everywhere in S, wherever we find anagram, what will be the size of that anagram? 3, because it needs to have the exact same characters. So the size of the anagram wherever we'll find will also be 3. Okay, so we'll create a window of size 3. So what do I mean by window? Let me explain. Let me erase all this and then we'll see how a window looks like or what we can do with it. Okay, so this is the question, let's assume, right? Now what I'm going to do is I'm going to create a window of size 3, and initially I'll keep the window here. This is my window initially. And then you have P. What you'll do is you'll just check, are these two windows anagrams of each other? First you have CAB, then you have BCA. Are they anagrams of each other? Yes. So you store 0 in your answer. Okay. Now you're going to slide your window. What does sliding your window mean? So the next character you'll put it in your window, and the last character you'll remove it from your window. So now the window will be like this because the window has slided. Now your window is this. Now this is your window ABD. Again you check, are these two windows anagrams of each other? No, they're not. Then again you slide, and then the window comes to be here. Then again you slide. So you keep on sliding the window. Eventually the window comes here, and then you check, are these two anagrams of each other? Yes. So then you store this index. Okay. So this is called sliding windows. You create a window of a fixed length, and then you slide the window each time you compare the string P and the that window. Now, how will we create that window? That is something to look for before we jump into the code. Okay. So every time we are adding a character to the window and we're removing a character to the window. Okay. So how do we create this window? So we can create this window using something called a frequency array. Now, what is frequency array? Pretty simple. Basically, let's assume that I'm creating a frequency array for P and then S. So let's create frequency array. Frequency array is nothing but an array of size 26, where each index corresponds to its character. So 0th index is for A, first index is for B, third index is for C, and last 25th index is for Z. So it looks something like this. Let's say int frequency of P. Frequency of P, size is 26. Okay. So initially everything will be 0. 0, 0, 0, 0. Size of this is 26. Okay. This is the 0th index, this is the 1th index, second index, all the way till 25th index. Okay. And likewise, one frequency array is for the S. Okay. And in this frequency array, we'll be storing the window. Okay. Now, initially, again, let's keep everything as 0, 0, 0, 0, 0, and 0. Okay. Again, indexing will be 0, 1 to 25. Now, let's store P first. So, P has B. So, what you'll do, you'll go to B's index, which is first index, and you'll make this as 1. Right now, it was 0. You'll make this as 1. Okay. And likewise, A is there, B is there. So, what will be the frequency array of P? It will be 1, 1, 1. Okay. So this is 1, this is 1, this is 1. Why? Because in P you have three characters which are B, C, A. So here you store B here, C here, A here. This is your frequency array of P. Now, like I said, we're storing the window in the frequency array of S. So initially your window will be starting from the first three characters or the first P characters. So initially your window will be C, A, and B. So again, what will it be? It will be 1, 1, and 1. Okay. So 1, 1, and 1. So this is your starting window inside the frequency array. And for checking whether they are anagrams of each other or not, you can just check whether the arrays are equal or not. If the arrays are equal, meaning they have the exact same characters in the exact same frequency of one another. So here you can see that frequency of P and frequency of S, both frequency arrays are same, which means that our window and P are anagram of each other. And that means that cab and BC are anagrams of each other. Now, how do we shift the window? So it's very simple. For shifting the window, you take the next character and you remove the last character. So how do you add the next character into the frequency array of S? Very simple. You take the next character, you go to its index, and then you add 1. So D is 4, 0 plus 1, 1. This will become 1. But you also have to remove the last character. So the last character is C. So you go to C's index and then you do minus 1. 1 minus 1 is 0. Now this is your next window. Again you check, are they equal? Is the array frequency of P frequency of S equal? No, they're not, meaning they're not anagrams of each other. You keep on going forward, you keep on sliding the window, and you keep on checking whether the arrays are equal or not, and eventually you'll be finding your answer and you'll be getting all the instances of P inside S. And now let's move to the code. Okay, so now let's take a look at the code and understand how what I said is happening code wise, how we're sliding the window, how we're matching the anagrams. Okay, so first thing that I'm doing, I'm just taking the length of S, storing it in N, taking the length of P, storing it in M. Now, understand one thing. If the length of string S is smaller than string P, if string S is smaller than string P, can you find anagram of P inside S? Obviously not. The size either has to be equal or S needs to be greater. So if N is less than M, just in case, we're returning a new empty array list because there's no answer in that case. Now, Then what we're doing is we're creating a frequency array for P and frequency array of S, just like I told you. Okay. Now, firstly, we're filling the frequency array of P with all the characters that are in P because this will be fixed. This window will be moving in S. The frequency array of P is fixed here. So we're just taking the characters minus A because getting to that index and incrementing that index. Okay. So here we are filling the frequency array of P. Again, we're doing the same thing. We're going from 0 to M and we're taking the first M characters or the first P length characters and then we're storing it into the frequency array of S. Okay. So this is the window is created with the first characters. Okay. The first window is created. Now the only thing we need to do is we need to slide the window and keep on checking whether the arrays are equal or not. So we'll be checking the equality between P frec and S frec, these two frequency arrays. Okay. Okay, so now let's move down below and see how we're doing the later things in the code. So after our two frequency arrays are created, I'm just creating a list of integers, okay, because we need to return a list of integers which are the indices. Okay, now what we'll be doing will be starting from M because the first M characters are already taken care of, and we'll be going all the way till N, which is the last character in string S, and we're checking are these arrays equal or not. If these arrays are equal, then I minus M, which is the starting point, needs to be stored in our answer. Okay, then what we're doing, we're sliding the window. So this is where the magic happens. This is where we're actually sliding the window. Like I said, the next character, the coming character, we need to add it. So the ith is the coming character, we add it. So we do I minus a, the index, we do plus plus. This is added to the window. The last character, which is I minus m, we need to remove that from the window. So we do that minus minus, we decrement it and the window moves. Again we check, we come into the loop again, we again check, are they equal? Then we slide the window. Again we check, are they equal? Then we slide the window. And after coming out of the loop, we have to check for the last window also, which is we're checking here whether p frec and s frec frequencies are equal or not. And in the end, we just return our result to see whether how many indices we got, and the order is also in the same order that it's appearing, but again that doesn't matter. Now we can just run this code to see how it works and whether it gives the correct answer or not. So let's just run this code. So you can see all the test cases are passing. Let's submit it. Okay, so you can see that we got it accepted, runtime of 9 ms, which is not bad. It is one of the top performing solutions. So that's it. That's how we can solve this find all anagrams in a string problem. Thank you.